Welcome to solverfy.
Okay, this question is asking us about what all isotopes have in common. Well, let's look at an example of isotopes. In fact, these are the simplest isotopes uh, that exist, right? So you are likely at this point familiar with the element hydrogen, right? When we identify hydrogen by its atomic number of 1, right? Which atomic number corresponds exactly to protons, right? So anything with one proton is going to be hydrogen or an isotope of hydrogen by definition, right? So a sketch of hydrogen might look like this. A P, that's our proton in the nucleus, and then an E, that is our electron floating around. Okay, here is our model of hydrogen. Well, what makes the next isotope of hydrogen, or as we call it, deuterium, is that we add a neutron to the nucleus of hydrogen, right? And so this is hydrogen. And this is deuterium. Or we can call this hydrogen 1 and this hydrogen 2. Because in fact, what determines what this superscript here will be is the total mass of the nucleus, which in the case of deuterium, we get one mass unit for the proton and one for the neutron. Right? Hydrogen just has one from the proton. Okay, so this is pretty much what isotopes look like. We always have the same number of protons from one isotope to another, otherwise it would be a different element altogether. But we change the number of neutrons. So another example of an isotope of hydrogen, it's H3, also known as tritium. Is that we have a proton, a neutron, and another neutron, right? So it's like hydrogen with 2 extra neutrons, still just 1 electron in its neutral form. Okay, so let's go through our options. They are identical twin elements. Well, no. I mean, deuterium is clearly not identical to hydrogen, is it? No, it's got a different number of neutrons. That is not what I would consider to be identical. What about they have the same atomic number? Well, yeah, in the sense that, for example, hydrogen, deuterium, and tritium are all uh, the first element in the periodic table. Hydrogen, right? Hydrogen 1. And we can actually add that to the symbol here. Atomic number 1, atomic number 1, atomic number 1, right? This subscript always tells us the atomic number of whatever isotope we're dealing with. So atomic number stays the same, yes. Oops. All right. They have different numbers of protons. No, no, they don't, right? Going from hydrogen to deuterium to tritium, we see that one proton, one proton, proton. What would happen if we added another proton to hydrogen? This would be helium, right? Atomic number 2. In this case, this would be helium 2, 2 minus. But in either case, 2 plus. But the point is, the second you add a new proton, it's not the same element anymore, because elements are defined by the number of protons they contain, or another way to put that is their atomic number. So this is not true. Finally, same number of neutrons. Well, no, we can see from the sketch that that's not true, right? Hydrogen and deuterium don't have the same number of neutrons, neither deuterium and tritium or hydrogen and tritium. In fact, keeping the number of protons the same and changing the number of neutrons is exactly what gets us new isotopes. So this is also not true. So the answer then is just same atomic